the fuck? It's gaming link. Whatever. There we go. You and the historians look at you and the historians look a lot more pixelated than you remember. You're inside a computer at the North Pole. Just as you're about to check out your surrounding, a program runs up to you. This region of memory isn't safe. The user misunderstood what a push-down automaton is, and their algorithm is pushing whole bytes down on top of us. Run. The algorithm is fast. It's going to cause a byte to fall into your memory space once every nanosecond. Fortunately, you're faster, and by quickly scanning the algorithm, you create a list of which bytes will fall in the order they'll land in your memory space. Your memory space is a two-dimensional grid with coordinates arranged from 0 to 70, both horizontal and vertically. However, for the sake of example, suppose you're on a smaller grid with coordinates arranged from 0 to 6 in the following list of incoming byte positions. Giving as each byte position is given as an XY coordinate, where X is the distance from the left edge of your memory space and Y is the distance from the top edge of your memory space. You and the historians are currently in the top left corner of the memory space at 0, 0, and you need to reach the exit in the bottom right corner. But at 6, 6 in this example, you'll need to simulate the falling bytes to plan out where it will be safe to run. For now, simulate just the first few bytes falling into your memory space. As bytes fall into your memory space, they will make that coordinate corrupted. Corrupted memory coordinates cannot be entered by you or the historians, so you'll need to plan your route carefully. You also cannot leave the boundaries of the memory space. Your only hope is to reach the exit. In the above example, if you were to draw the memory space after the first 12 bytes have fallen, it would look like this. You can take steps up, down, left, or right. After just 12 bytes have corrupted locations in your memory space, the shortest path from the top left to the exit would be 22 space, here marked with 0. Simulate the first kilobyte falling into your memory space. Afterward, what is the minimum number of steps needed to reach the exit? So is that 01 BFS? The 01 BFS is with the deck, right? So there's 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. the shortest path is 22 steps. Here marked with O is one such path. Simulate the first kilobytes falling into your memory space afterwards. What is the minimum number of steps needed to reach the exit? Wait, what? So you only need the first kilobyte. So I guess the input is bigger. Yeah, the input is just bigger for question 2, I'm guessing. So this is looking like 01 BFS. Oops. Okay. I guess I'll load all of this in memory. One, two, three, four, five, six, 7. Okay, so it's 7 by 7. So I guess we'll call this. Is it a square grid? Yeah, it's a square grid. So let's call it n is equals to 6 for this example. It's actually equal to 7. Yeah. And you need the corrupted bits. So then for a line in file, corrupted bits dot append, and then we're gonna strip it. So line dot strip, and then we'll split it at commas, and then I want to go for each for x, y in this, and then we're gonna do some list comprehension, and then this is what, and we can have it as a tuple. Oh no. Oh wait a minute. Oh no, so this is I'm trolling, so after I split it I have x and y. Wait, no, not yet. I want after I split it, it's gonna give me these two but as strings, and I want them as integers. So I guess no, I'm too lazy. I'll just cast them here. There we go. Then print corrupted bits. Yeah. So next we want the grid. So the grid is gonna be times n for whatever in range of n. Okay. Wait a minute. I guess I'll do dots and hashtag just like them. And then here we're making 12 bits fall into the corners, 12 bits fall into the grid. So for I in range, well, I don't care about the I, so for whatever in range of 12, actually I do care about the I. We're gonna make grid at a corrupted bit. Row and column equals to corrupted bits at I. Set the row and the column to a corrupted bit. And then let's print the map. Okay, let's turn it into a string to make it look like what we have in Advent of Code. So this is what it looks like. Ah! Why is it wrong? It looks upside down, backwards. Wait. Oh, X is distance from the left. So that's column. Oh my god, so cringe. Y, X. And that fixes my problem. There we go. And then we want to run 01 BFS on this grid starting at 0, 0. Okay, so to run 01 BFS, we want a deck. And initially in the deck, it's gonna store coordinate and distance. So distance of 0 and then coordinate is 0, 0. So we're gonna do, and we'll have it as a tuple. And then here I'll put a comment because I'm a good boy now. So distance, row and column. Okay. And I think the input for the deck constructor takes an array. Okay. So to run 01 BFS. Okay, yeah, so while we have stuff inside, you want to take whatever's on the left. So the dot pop left, and this is our current one. Oh, and then here I want to have all the moves. So the moves are 1, 0. I'm working on Advent of Code Day 18. I can put the link in the chat if you're interested to see it. That's 1, 0. 0, 1, and 0, minus 1. So then explore each side. So actually, don't want to call it current. I want the distance, the row, and the column. And then for dr and dc removes if, so here we're checking for bounds, so 0 smaller equal, yeah, it's coding challenges for Christmas. Usually I do Leetcode. Well, I did the daily today already. It's pretty easy. And then every day until Christmas there's Advent of Code. Right now I'm on day 18. I don't know which day it's gonna get too hard for me. This part 1 is looking easy. Part 2, I'm kind of scared because yes it is. Part 2 is really hard. So this is row plus dr is less than n. And column plus dc is less than n. So wait, is it 0,1 DFS? No, it's not even 0,1 DFS. Every move costs 1. So it's just breadth for search or depth for search. I mean, I could DFS. DFS might not give me the shortest path. Dijkstra doesn't make any sense because I'm adding by 1 every time. Leetcode. I think Leetcode I'm at day 45 of my streak. And I think I'm at like 350 questions solved so far. 361. And I started doing Leetcode contests 2 weeks ago. Yeah. No, it's not even 0,1 BFS. 0,1 BFS is only used if a move is either free or cost 1. This is just regular BFS. Yeah, so just BFS it. So I'll just use the deck as a queue, that means. So if they're inbound, the queue.append, the distance is gonna increase by 1. So it's gonna be distance plus 1. The row is gonna be row plus dr. And column is column plus dc. Yeah, so I think that's it. And then here it's just a check of if row and if row equals to n and column is equals to n. Then this is where we found the answer. I guess print the distance and break. So then let's try this. Oh, it's infinite looping. 0. Okay, let's just print distance, row, and column. Oh, and I forgot to have a wall check. Yeah, that's a problem. I mean, even if I didn't have the wall check, it shouldn't. Okay, whatever. And grid at row plus dr, column plus dc is not equal to hashtag. Okay, let's try this. Oh my god, it's so slow. Oh, I should probably have a visited set. Visited dot add one column if row and column and visited, then continue. I think that should fix my problem. Wait, does it never get to? Okay, yeah. Okay, it's n-1 here that I want actually. Yeah. So 22 is the answer, that's correct. Now simulate the same but with the puzzle input. Instead, n here now is 70? 71, right? Yeah, because it's anything 0 to 7. Oh, wait. Yeah, it's 77, so it should be 71. $140? Oh. Did I misunderstand it? Oh, simulate the first, yeah, I forgot to so here instead of non-corrupted equals to 1024. There we go. Is there gonna be a delay? Oh, gotta wait. Okay, might as well read to make sure I didn't troll again. Okay. Yay. Now it's part 2. Okay, part 2. The historians aren't as used to moving around in this pixelated universe as you are. You're afraid that they're not going to be fast enough to make it to the exit before the path is completely blocked. To determine how fast everyone needs to go, you need to determine the first byte that will cut off the path to the exit. In the above example, after the byte 1 falls, there is still a path to the exit. However, after adding the very next byte, 6-1, there's no longer a path to exit. So in this example, to coordinate the first byte to prevent the exit from reach is 6-1. Simulate more of the bytes that are about to corrupt your memory space. What are the coordinates of the first byte that will prevent the exit from being reachable from your starting position? So I think this is easy. Okay. How would I go about that? How do you know if it's blocked off? I'll try to brute force it, see how slow it is. Okay, so this is traversal here. Yeah, so let's put this into a function. Okay. So let's do something simple like this. And then I want to iterate through the number of corrupted bits for I in range of okay, so now instead of num corrupted, I want the length of corrupted bits. Okay. I don't know if DFS would actually be faster. No, probably not. I don't know. No, probably not. Okay, so we're gonna add this and then we're gonna run BFS on the grid. So then we're gonna run BFS, and if not BFS, then we're gonna print row column. So this is the one that's gonna block the BFS from being able to complete, and we're also gonna break. I mean, spoiler, it's too slow. But let's see if the brute force works for the first example here. What? Okay, so six one is supposed to be the first one that blocks it, but apparently it's not blocking. Oh, what the fuck? Okay, I don't think the grid is being modified. Oh, okay, that's why. Should be of n equals 7. Okay. 1-6 is the answer. So brute force is working. Oh, and I have to be careful because xy is actually an inversion of that. Let's see how slow it would be. It's actually not that slow, right? Wait. Let's check the length of the corrupted bits. Whoops. $3,050. 3,450. Brute force might work actually. I'm not sure. Okay. I think brute force is gonna work. Okay, there we go. 2622. Oh, that's it. Okay, wow. Thanks for watching, everyone. Woo! Bye bye.